Today what we are going to discuss is one of the very important phenomena in optics, that is the interference. It is demonstrated by one of the scientists, that is the Young's scientist. In 1801 he demonstrated one of the experiment that is very important from examination point of view, as well as if we go through the other examination relating to the competition also. Now, actually what is Young's double slit experiment? Today what we will talk about this only experiment is Young's modulus experiment, actually the experiment that establishes the wave nature of light, because the light, if you know very well that the light, white light, it consists of various wavelengths, red color maximum wavelength, then we have other colors wavelength going to decrease. And in Young's double slit experiment, what happens actually, and what is the nature of the light used in the double slit experiments, and what are the various conclusions that has been drawn by the Young's, that we will discuss today. First of all, let us talk of what is Young's double slit experiment. Double slit experiment, in the name is there that there are the two slits. Single slit, it is not performed, we have two slits are there. If you see the first figure, students, very clearly, that the first figure says that if the light were of the particle nature, if the light were of particle natures, directly it is passing through the two slits as you see in the figures, you will get the patches of the color over their bands of colors. But you know that the light or light waves are there. So if the light, it behaves as a waves. So what happens if you see in these figures? So there is a source. This source gives the wave fronts. So wave fronts, they are spreading out. They are going like this way, they are spreading out. When they spreads, and we have two slits are there, and these two slits, they are very narrow slits. And moreover, the distance between these slits is very small, that is in mm, right? And 0.5 mm or 1 mm we generally take. And then we get here is, that is the screen is there. On this screen you will see that the dark and the bright patches are formed, and here the central maxima is also formed. So this is what is, it is due to one of the phenomena which is demonstrated by the Young's, that is called interference. Because whenever we have a source of light, you very well know that this source of light, it will give you the disturbance, it will give you the light waves in all the directions, spreading out wave fronts, but after passing through these two slits, it will become a secondary wavelets over there, and you will see that there are some semicircles are there which are crossing to each others. So what happens actually, that there are the two things are formed over here. So one is crest, another is trough, because you know that the light is electromagnetic wave. So crest, trough, they are formed. Crest is there, trough is there. So crest and troughs, they are going to overlap in this experiment. So when they are going to overlap, what happens, that if the crest of one wave, because the waves that are emitted from this, if you see this slit, from this slit, if the secondary wavelets, they are coming out, and from here also. So therefore when these two waves are coming out from here, and there is a phase difference, suppose it is there, because the extreme point we will take, if there is a phase difference between these two waves, but this should remain constant, it should not change. If it remains constant, then what would happen, that there we will get the coherent sources. These two slits behave as a coherent sources. So coherency means that emitting of the light waves of same wavelength in the same directions with the zero phase difference, or if phase difference is there, that should remain constant, it does not change. So if you see in these figures, there are the wavelets, secondary wavelets coming out, crest and troughs, they are going to overlap. Crest of one, crest of others, they overlap each other. So, similarly, the trough of one, the trough of another, so they are also overlap. So, where there these two things happen, the crest of one overlaps the crest of others, we will get interference. Similarly, the trough of one overlaps the trough of others, that is also called, here is also interference is formed. Now, then what is the nature of this interference? Actually, what is interference is there, what is the nature of interference is, that is very important, which are demonstrated by Young's. Now, interference is what? Actually, there is a redistribution of the energy. Energy is redistributed, it is not created, it is not destroyed. So, if the energy is redistributed, it means if the crest of one falls on the crest of others, overlap, and the trough of one falls on the trough of other like this way. So, what we will get? Interference. So, crest of one falls on the crest of others, we will get one of the name, that is called constructive interference. And similarly, the trough of one coming out of the slits falls on the trough of other, that is called the also constructive interference. So, it means the constructive interference is that interference where there is a overlapping of the crest of one and the crest of others and the trough of one and the trough of another way. So, similarly, sometimes what happens in this experiment when Young's performed, he also got one of the new thing, that is called the destructive interference. So, where the destructive interference is actually formed, that is very important. So, destructive interference means the crest of one, the trough of one, crest of one wave, the trough of another, they overlap. When they overlap, so what happens? We will get an interference, and that interference is known as the destructive interference. So, therefore, Young's modulus, this Young's double slit experiment, what does it indicate? It indicates only the wave nature of light. Wave nature of light is establishes by this Young's double slit experiment, and moreover the interference. Interference is just, it is the redistribution of energy, right. And when we have to see in your most of the books, you might have seen this picture, students, very clearly. Now, how to produce actually this interferences? That is one of the most important condition we require over there, and that condition is the coherency of the sources. Now, coherency of the sources, what is? That the system should be coherent. If you see in the figure, that is S1 and S2, there are the two slits are there, right. In these two slits, here one source is there. If one source is connected over here, what is this one source? You can connect a bulb, you can connect another sodium lamp, right. Any type of source you can put up over there. So, laser can also do like this way. So, this will give you the light waves in all the directions, right. You see, that is the wave fronts which are formed over there, and then we will get two slits. These two slits actually what they do, these two slits behaves as a coherent sources. Now, what are actually coherent sources is, that is very much important, that the coherent sources are those sources which give you the light waves which are in phase, there is no phase difference. If phase difference is there, that is constant. And secondly, the wavelength, that is of the same, right. It is the waves, they are traveling in the same directions. So, therefore, what will happen? So, you will see that there are the dark and the bright fringes you are going to see here on this, patches are formed on the screen, right. So, therefore, this bright, dark, bright, and you will get the alternate fringes are there, a band of fringes you will get over there. So, you will see that the crest of one falls on the crest of others, you will get constructive interference. The crest of one falls on the trough of others, you will get the destructive interference. So, it means that the Young's tried to establish the wave natures. He tries to explain the interference on the basis of the Young's double-slit experiment, and with the help of this he got number of other things also, theoretically also. Now, how to prove that what are the various expressions for the, suppose if you have to calculate the intensity, what sort of intensity you will get, because the different fringes are formed. It means we are very curious to know that what are the intensity of this, what is the resultant of, isn't it, what are the resultant of the superimposing, because you see that here what is there in this experiment, simple demonstration is there. What is that expression? Is expression for the amplitude, if we will get, that is, and moreover the intensity for the interference. Now, the light is passing through these two slits. These two slits, they behave as a coherent sources. They behave as a coherent sources. So, coherency means, again I repeat you that the coherency is that when the light waves, they have the same wavelength and zero phase difference, or if it is there, phase difference is there, that should remain constant, it does not change. So, suppose one of the wave is traveling, that has been given by, we just take the displacement of first wave, suppose y1, that is equal to a sin omega t. Another wave we take, that is y2, which is equal to b sin omega t plus phi. Phi is what? That is the phase difference. We take extreme step, that is the phase difference is there, but this should remain constant. And between the screen as well as the slits, the distance is taken as capital D, and then between the slits we take the distance as small d, and the distance from the center, that is small, you just see, this is actually from this O point, this is from O point, O to P, this distance is x from here to here, not from here, this is from here, clear? Now, this will remain d by 2, small d by 2, this will also remain as small d by 2. So, this you please make it correction over here, that this is from here, this distance is x from center up to this. Now, you know the superposition principle. Superposition, now we are just taking here two waves are there. They are going to superimpose. When they are going to superimpose, it means the resultant displacement that is given by, so y is equal to y1 plus y2. Clear? Now, you substitute the values. So, y1 is equal to a sin omega t, and y2 is equal to b sin omega t. A is the amplitude of the first wave and b is the amplitude of the second wave, and phi, what is phi? That is the phase difference we are going, but this going to take, but this remains constant, it does not change, because if changes we won't get the patches of the interference, interference is not over there, right. So, what will happen is that y is equal to the resultant displacement we are going to calculate, because the superposition principle says that the number of waves going to superimpose upon each other, the resultant displacement is given by the vector sum, right. So, therefore, this is a sin omega t. If you open, this is sin a plus b formula is there. So, this is b sin omega t cos phi, I have multiplied over there inside, that is b cos omega t sin phi, clear. Now, what will happen is that you just collect all the terms that contain sin omega t, and then you contain here all the terms which are having cos omega t, right. So, sin omega t, if you see there, that is the sin omega t is lying over here also, sin omega t is also there. So, I have taken sin omega t out of this, a is left here, here b cos phi is left. So, here cos omega t plus b sin phi, clear. Then we have made here substitution is there. Students, I have told you earlier also, why do we make substitutions, why do we suppose? Because in the science one thing is very important, that the supposition is there just going close to reality. अगर असी सपोज नहीं करते, असी रियलिटी के नेड़े नहीं जा सकते. ਸੋ ਰਿਐਲਿਟੀ ਦੇ ਨੇੜੇ ਜਾਣ ਲਈ ਸਾਨੂੰ ਕੁਝ ਸਪੋਜ਼ ਕਰਨਾ ਪੈਂਦਾ ਹੈ। ਤੁਸੀਂ ਲੋਅਰ ਕਲਾਸ 'ਚ ਵੀ ਕੀਤਾ ਹੋਏਗਾ ਕਿ ਆਪਾਂ ਕਰ ਲੈਂਦੇ ਹਾਂ ਕਿ ਸਪੋਜ਼ ਇਹ ਸਾਈਡ ਇੰਨੀ ਹੈ, ਦੂਸਰੀ ਸਾਈਡ ਉਸ ਦਾ 2 ਟਾਈਮਸ ਹੈ, ਤੇ ਐਂਡ ਤੇ ਆਪਾਂ ਕਰ ਲੈਂਦੇ ਹਾਂ। ਸੋ ਇਟ ਮੀਨਸ ਸਪੋਜੀਸ਼ਨ ਇਜ਼ ਮਸਟ. So that we have tried here sum, that is a cos phi, that we have substituted here. This is r cos theta and b sin phi, that is equal to r sin theta. If you substitute these values, you will get these relations, right? R we have taken it out, and now you left here, this is sin omega t cos theta plus cos omega t, right? This is sin theta. Clear? Now then the resultant displacement is given by r, because you know very well that is sin a plus b formula. If you evaluate it, you will get sin a cos b plus cos a sin b. So therefore you will get r sin omega t plus theta. Now what is this r actually is? This r is the resultant of, this r is the resultant amplitude, this is the amplitude of the resultant wave. Because there is a superpositions. I have told you that whenever the crest of one falls on the crest of another, the trough of one falls on the trough of another, you will get some interference. So crest of one, trough of another, you will also get an interference. But here you will get a destructive interference. So here you will get a constructive interference. So this r is known as the amplitude. This amplitude is the amplitude of resultant wave. Clear? So then this can also be calculated very easily. If you go through here, we have substituted values, that is a plus b cos phi is equal to r cos theta, and b sin phi is equal to r sin theta. So what you do, what we have to do here, ਤੁਸੀਂ ਵੀ ਆਪਣਾ ਕਰਕੇ ਦੇਖੋ, ਇਹ ਦੋਨਾਂ ਨੂੰ ਬੇਟਾ ਸਕੁਏਅਰ ਕਰ ਦਿਓ. You just square this one on both sides and square this on both sides. Then you add these two equations. R square cos square theta, a plus b cos phi, square of this, b square sin square phi is equal to r square sin square phi. Clear? So then what you will do, ਸਾਨੂੰ ਪਤਾ ਹੈ ਕਿ cos square theta plus sin square theta, that is equal to 1. On the left hand side you see we have directly substituted, that is equal to 1. So it means r square is equal to a square, right? b square ਦੀਆਂ terms ਇਕੱਠੀਆਂ ਕਰ ਲਈਆਂ ਬੇਟਾ, cos square phi plus sin square phi plus 2ab cos phi. So again this is cos square phi plus sin square phi, that is equal to 1. So you will get r is equal to r, which is the amplitude of the resultant wave, this r, which is equal to a square plus b square plus 2ab cos phi under the root. Now why we have calculated this r? This question is very important here, because all we know that the intensity is directly proportional to the square of the amplitude. Right? Suppose we have first wave is there. If in the first wave we try to calculate what is the intensity, because the amplitude is a, if amplitude is a, it means the square of the amplitude of first wave is a square. इसका मतलब this is directly proportional to the I1. I1 is what? That is the intensity of the first wave. Right? Because the resultant intensity or the intensity of any wave is directly proportional to the square of the amplitude. Now here we have calculated the amplitude of the resultant wave. So therefore we will write down that the resultant intensity I, which we getting here due to interference, that is the intensity is directly proportional to the square of the amplitude of the resultant wave. So therefore I is directly proportional to r square. So therefore I is equal to a square, right, proportional to a square plus b square plus 2ab cos of phi, right. So this is very important from your competition point of view as well as when you are going to do your numerical problems. because in the numerical problems you have to calculate, suppose sometime intensity you are given amplitudes and phase angle is given. So, therefore, it is very important to calculate. Here means you are getting here 3 formulas are there. The first is R is equal to A square plus B square plus 2AB cos phi. So, this you have to remember, note color please. And then the second formula you have got it over here, that I is directly proportional to R square. I have told you earlier also that this I is the intensity of a resultant wave. So, ਇੱਥੇ first wave ਦਾ ਵੀ ਕੱਢ ਸਕਦੇ ਹੋ ਤੁਸੀਂ, it means I1 is proportional to small a square, because small a is the amplitude of the first wave. So, similarly you can also calculate the amplitude of the second wave. So, this I2 is proportional to B square, right. The third you have got it here, that the I is the intensity of the resultant wave. So, it means you have got 3 formulae are there, that first is the intensity is proportional to, directly proportional to the square of the amplitude, and then the the R, that is equal to under root A square B square plus 2AB cos phi, and third is this. Now, what are the conditions? ਅਸੀਂ ਇਹ ਵੀ ਦੇਖ ਲਿਆ, we have seen that there is a constructive interference, we have seen there is a destructive interference. So, it means there may be some mathematical conditions that we have to keep in mind, right. It means where there is a constructive interference, the crest of one, the crest of other overlap, you will get maximum intensity. When this will be maximum? You have got here cos angle. You very well know that the cos angle has maximum value plus 1. So, this is maximum if you will substitute suppose 0, cos 0 is 1. So, it means this is 2AB, right. So, it means this is 1, this is 2AB, you will get here A square plus B square plus 2AB.